Hi, just here I want to introduce the first part of this chapter. We're going to talk about heat and temperature. Now, one thing that I need to say here is that heat and temperature are two different physical quantities. They are not the same quantity, although in daily life we are talking about them as if they have the same meaning. They also have different units as well, as I will explain in a little bit. Now, we define temperature as it is the state that determines the direction of heat. For example, here, if you have here, this is as a cup of coffee, let's say, and it is at 100 degrees Celsius. And this is like I will say, it's the air in the room. And then the heat will be transferred from the higher temperature to the lower temperature. Now, these objects, the who's going to exchange the heat, they should be in thermal contact. And the thermal contact, when we have a physical contact, that is going to make the heat transfer possible. Heat naturally will flow from hot to cold. Also, temperature, it is related to kinetic energy of molecules of materials. And for materials, we have actually three types of motion. The first one is the translational motion, and this is when the molecules are moving from one place to another. And we have rotational motion, then there is an axis, and then the molecule is going to rotate around, or vibrational, where the molecule is going to vibrate. Temperature has to do only with the translational motion, and we will talk about this later when we are going to introduce the kinetic theory of gases. Now, let's go to the other quantity. It is heat, and heat, it is one form of energy that is existing only when energy is in transit, which means when we have an exchange of heat. Objects do not contain heat. You cannot say this object contains 400 joules or like 400 calories. We can only talk about heat transfer when there is a difference in temperature, and then the heat transfer will be initiated. Units of heat and temperature. Now, based on the new definition for heat, as it is related to energy, then it has units of joule. Calories, there we have units of calories, and it is the amount of heat required to raise the temperature of 1 gram of water from 14.5 degrees Celsius to 15.5. Now, the food calorie, this is here, the food calorie, and it has a capital letter, and that is equal to 1,000 calories of the ones that I'm talking about. Now, for units of the temperature, it depends on many factors. Like, for example, when we're gonna talk this in science, we are going to talk about Celsius scale. Now, for Celsius scale is considering two fixed points. One of them, it is the melting point of water, and the 100, it is the boiling point. And then they divided the distance between these 2 points into 100 degrees. And each is going to be like called 1 degree Celsius. Now, the oldest one, the first, and like actually Fahrenheit was the first one to have these small thermometers for measuring human temperatures. We are using 32 degrees Fahrenheit for melting of ice and 212 for boiling of water. And then they are dividing the distance into 180 degrees. Therefore, 1 degree Fahrenheit is like smaller than 1 degree Celsius. If we wish to convert between these two scales, actually this is, in the United States we are using Fahrenheit widely. TF, which is the Fahrenheit temperature, equals 9/5 the Celsius degrees plus 32. For example, I will show you here. If I want to convert to 12, does it equal 100? I'm gonna put the equation here. T Fahrenheit equals 9/5 TC plus 32. And then I'm gonna plug in the numbers. Now, in order to solve this equation, subtract from both sides. Then we're gonna get 180 equals 9/5 TC, and then TC, it is 5/9 times 180, and that is 100 degrees. Now for the Kelvin scale, that one is the one that we are using in all the equations. Anytime you're gonna have an equation where T is by itself, not delta T, because delta T we don't convert because the conversion is gonna disappear. And it is the SI unit of temperature. SI means the standard system of international units. Now, more than one scientist studied the relation between the pressure and the temperature of a gas, a constant volume. They studied the relation between pressure and temperature. And I will say one scientist found this line A, another scientist defined B, another scientist did find C. And when we tried to connect the points, all the lines, they intersected in one point, which is negative 273.15. The importance of this point that P here equals 0, and this is also maybe what is making it very difficult to achieve. We agreed on we want to have this as the absolute 0. Then I will say the absolute 0, it is negative 273.15 degrees Celsius. And now, if we want to convert from Celsius to Kelvin, we need to add 273.15, or we can really make up the approximation and use only 273. Thermal contact, it is when objects are put into contact and they will be able to transfer heat from one object to another. Thermal equilibrium will be achieved when the two objects reach the final temperature, which is the common temperature between them. Now also, I want to introduce the zeroth law of thermodynamics. From its name, zeroth, it's like very easy to prove. It's a common sense thing. Two systems that are each in thermal equilibrium with a third system are in thermal equilibrium with each other. Then if I have, let's say this is a thermometer that measures the temperature of B to be a number, and then the thermometer also again here was used to measure C, and we have the same reading, then we know that B equals C. The temperatures, they are really equal. Thank you, and I will see you in another video. Thank you.